Hi guys, what you're looking at is evolution of my geometric neuron idea. At this time we are after qualia. So what is qualia? Qualia is the subjective experience of the world we have, and here when we are messing with the geometric neurons we have something a little bit like qualia. Why not? These are the geometric neurons underlying everything. And this is the point where I'm going to tell you guys that I should not be taken seriously because I have brain damage. And because I have brain damage, perhaps I am chasing this idea so bad. I have sort of autism, I guess you could say. But anyway, so what is a geometric neuron? How was it born? And once again, the same old story. First of all, I'm going to interject here and say that in my vision at times I may have these sorts of changes. Um, Looking at certain sorts of like patterns, like if you have certain sort of a grid, I can start to see these kind of they are kind of bothersome. But well, perhaps that's just a coincidence. But anyway, so geometric neuron was born here at this comfy UI like node-based graphical user interface system I did, where you could load different nodes. So I made 600. I was bored and made 600 different nodes for this system. And anyway, that was last year, long winter. And so what I had heard about neurons was that they try to stay in homeostasis, and so we made a homeostatic coupler, and that was that. I don't know. I think it was based on it was for some other idea actually. I just homeostatic coupler, and then I was also doing like visualizations. Like I wanted to do visualizations because ComfyUI does those. I mean, it uses different sorts of AI nodes to build different sorts of visualizations, and so I was doing something like that. And so I had a homeostatic node. And then one day I was half dead and threw cables from homeostatic node, took a thing here and took a signal and made it to go to a checkerboard node. And from there, I guess I was even more bored. I had image to vector node, so I turned that image into a vector. So what that means is that if you have, let's say you have image, so you have lines, kind of like scan lines. They go like this, and that scan line thing, that's just a long number. So we turned the whole image into a long vector, and then what happened? We turned that into sent that signal forward to a vector splitter. So we subdivided that into here 16 numbers, and we sampled those numbers back to homeostatic coupler. And what happened was once again was that we got ecg signal, and I'm like, holy Jesus, why are we getting ecg signal? And then I noticed that when we are changing, if we have different amounts of these lines going to the homeostatic coupler, we get a different signal. If we had different size master vector, we would get like completely changed signals. So here we are getting a sawtooth and so forth. And then I thought, what if the surface of a soma that has ion channels somehow makes this grid? And I slowly learned that what we have, like the dendrites they are delay lines. They are delaying the signal coming from the next neuron, and they are kind of like bad wires. They are, and you could describe them with something called the cable function, which gets, let's just say, very very complicated. And then I slowly found out that there is a thing. There is of course action is sending signal forward from the neuron, and there are actually smart people thinking about this instead of just dumbass brain dead idiots like me. And here is a guy, Christophe Leterrier from France, Aix-Marseille University, and he's been thinking about this a lot. And so he's been looking just at this tiny little thing. Imagine, guys, you are just thinking of this tiny little thing here, axon initial segment. And he's been thinking about this, and so it's just this tiny little thing which has microtubules and it has actin rings. And these acting rings are kind of like what I've been thinking of lately, and it's been kind of like, if you guys notice, they are spaced. They are here 190 millimeters apart, and there's multiple of these. Now, so the signal is passing through this, and it's being gated in. There is a certain sort of a gate here. Let's see. Let's go back to our code. I'm trying to think. So here is our code. So there's certain sort of a gate, and the signal as it's passing through. So since we had a perception lag workflow, and here, if this would be the soma here, and this system kind of is missing the ace. The ace would be somewhere here, so action initial segment. So, oh, where would it be? Would it be actually here, actually from the, okay, so this is not really a even attempt. That was kind of how I came up with the geometric neuron, but now what would those gradings be? What would the gradings be in the action initial segment? And again and again and again, as I've been doing this sort of stuff, what comes up is holography and holographic systems. And of course, what holography we usually know it from, you have a laser plate, so you have some sort of a glass plate, you shine a laser through it, and you can get three-dimensional image. And conveniently, we are living in a world with three dimensions, and well, that's kind of convenient. And not only that, in physics, some people think that the universe actually exists on some sort of a membrane. Very, 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 very smart people, Susskind and Tuft, who were thinking of the string theory. Anyway, so they think that there's some sort of membrane, and the dimensions are projections of the membrane, and suddenly we are looking at the ace and we are thinking of exactly the same thing. We are thinking, so you have those things, what if they are projecting the world? Now, where are they projecting the world? So there's one neuron. One neuron probably won't project the world. It projects something a little bit. It has a little ace. But now imagine, guys, you have 83 billion of these things, and you have something in the back of your brain, frontal lobe, all these doing different things, all these things being gated in a different ways. Now thinking about all these things, because I'm brain dead idiot, and I think about things too big for me, so I came by this accidental discovery that when we look at actually into the brain, and we have the so we have here, we are loading actual EEG, and when we are loading actual EEG and we are sending out frequencies, and we are sampling only the theta frequency from the frontal lobe, and okay, we are amplifying it a tiny little bit, and we are using this Taken's algorithm that compares the signal against itself. So the Taken's algorithm, once again, Taken's algorithm, so it's comparing signal against itself from the past, but in our systems it's a stand-in for the dendrite delay lines, clear as mud. So the dendrite delay lines are growing, dendrites are growing at a time. So I'm slowly coming to think that what if these dendrites are growing a relationship to another neuron to encode something. So there's the external world, and the external world here, we see the external world is webcam image, but at the same time, through our eyes, we are taking something very similar in. We are taking light through our senses, we are getting electric impulses. Through our nose, we are getting scent. Through our ears, we have cochlea is taking in information, it's encoding it in the cochlea, which is kind of this oyster shell-like thing. It's coming through 1D impulses. And so we just have 83 billion neurons connected together with wires and a haptic field. And here, when we take the actual signal from actual brain, from in actual data frequency, and we are looking at it with the Taken's delay line, so we kind of make a tractor out of it. We compare it against itself. What we started to see with the Taken's was that with the exactly data frequency, it's creating a box attractor. here. You guys can see at alpha it makes a little bit shittier box. At different frequencies it makes different boxes. But so now we are simulating a little bit of the brain outside of the brain. We are getting a little bit of the signal from this population of certain electrode, and we are getting these attractors. And slowly I started to become aware that okay, so brain has attractors. The manifold, you could say, the neurons, they make a manifold. They are firing, they are shooting, they have their very complicated stuff. There is the liquid, which is the spinal fluid, which has cells moving about it, try to sucking in all the ions so that these neurons do not conduct between them other than with the wires. And then there's the haptic coupling, which was only really discovered and understood a couple years ago. But anyway, so it's a kind of like this isolated islands, and if the geometric neuron idea was true, then they're kind of like they're spectral islands. They are holding certain sort of tiny bit of spectra, they are firing with each other, and as you are watching something, what happens is that they are creating some certain sort of understanding of the world, and they have a certain sort of energy budget. If you are watching something, if you are thinking about something, you start to feel tired because as they are firing, they are using huge amount of electricity, a huge amount of calories, and they get tired, and then you're like, what the fuck am I saying, and what the fuck am I doing, and what the fuck am I seeing? But your brain is like, okay, you are probably seeing that, you are probably seeing that. So there's no more thinking going on. You are just like, okay, you are probably seeing a screen, and you are probably talking to yourself, and nobody's listening, and you have created some sort of weird ass thing, and you wonder if this is the qualia, and if you figured out how the brain works. But so this is a state. It's a state of the brain, and in this case, if my idea was true, then this is where we all exist. We exist in a world of these spectral islands, neurons that have certain sort of a state, and when they are firing, they are trying to communicate something down the line. The singular spectral island, the singular neuron, then it's trying to communicate something, some sort of a change. I think predictive coding or something it's called, whatever, don't take my word on anything. But anyway, so they are trying to stretch to fit the world. So we are in a world, I know I have a poster there, I have Phil Collins there, I have the crown of Jesus Christ on there, and there's a Christmas sock there, and I don't have to look at them. They are part of my being. And how they are part of my being, if this theory was true, then the ace gradings, these holographically are a certain way. With time they have become a certain way. They are the holographic plate. The neurons have become a holographic plate, spectral holographic plate, where the ace gratings have become a certain way. The ion channels making a certain sort of a grid, if that idea was true, they have become a certain way. The synapses have taken a certain form that tell me every single fucking moment that I'm a anti-Lude, the brain damaged guy who is thinking about things too big for me, who has created this weird ass thing that somehow kind of looks like a damage in my brain sometimes. But so this is the geometric neuron idea today, and I think the new thing that's slowly being developed is that this would be sort of kind of like the birth of qualia, the grading. It would be a grading. The signal comes through this, and every time when the signal comes through this from the neuron, firing through this soma, so these would be the islands where the information is. They fire through the thing. They either fire or don't fire. So here would be a thing, and when these things start working together, we get something like this. Clear? Get it? So probably this is how everything is, but then again, most likely, perhaps no. But yeah, thinking about stupid shit. I hope you guys are well.